Welcome students, welcome to the next session of structural analysis 2. So in the previous classes we have started moment distribution method and we have started a problem to analyze a continuous beam with the moment distribution method. Okay, firstly we will go with a short brief notes and then we will go into the continuation step. Okay, so we have observed a continuous beam which is having simply supported ends at A and C and it is being subjected to UDLs over two spans. Okay, for the first step we are evaluating the distribution table for the distribution factors. Okay, so the distribution factors we have calculated according to the lengths and we have observed these are the steps we have finally got. Initially joint, member, the corresponding relative stiffness, total relative stiffness and then finally the individual distribution factors for the spans. And then our next step is calculation of the fixed end moments and the corresponding fixed end moment calculation we have done with the individual loadings and individual intensity of the loadings and lengths and the corresponding load and length. So whatever the formula we are using when a beam is having over Ln and with an intensity W, the corresponding fixed end moments are WL square by 12 and WL square by 12. When a beam with a point load, fixed beam with point load at center, the corresponding is WL by 8 and WL by 8. Please remember the first step itself, these are the answers. If you forget the formulas, you will not cope up with the next steps. Okay, so point load at center, UDL over entire length, and then eccentric point load with A and B, WAB square by L square, WA square B by L square. So in this way, the fixed end moment formulas you should have to involve. So whatever the loading they have given, the corresponding formula you use, taking each span as a fixed beam. So first span, the corresponding answer, second span, the corresponding answer. And the next thing you should have to write is, in the moment distribution method, the anti-clockwise considerations will be considered negative. The anti-clockwise moments will be considered negative and the clockwise moments only will be considered positive. As the fixed beam is showing some hogging resistance to stop the beam to bend, it is resisting from the supports. That's why those two will come for the fixed beam like this only. So due to those hogging conditions, the hogging moments in anti-clock and clockwise manner, this is becoming negative and this is still positive. So those answers we have written and then we are entering into the moment distribution table and we have indicated the joint names, distribution factor indication and the corresponding fixed end moments. So in this way our step has completed. And then the next thing is making the corrections for the simply supported ends. So in the actual structure we have observed the simply supported ends. That's why we have given for the correction of the support moments. Okay, so the simply supported ends were corrected and then the corresponding carryover moments will be transferred and we have got the simply supported ends correction, simply supported ends correction, the corresponding carryover moment with as it is sign but half quantity, the corresponding carryover moment with as it is half quantity. Okay, as it is sign and half of the quantity. Now the completion was over for the supports. That's why we will indicate with a two solid lines and we will sum up the answers. We will sum up the answers here itself and you can observe the final moments are 0 and at B towards A is something, at B towards C is something, at C is 0. So the corrections were completed but the balancing not at over at joint B. Okay, A and C finalized. At B no completion over. So at B I should have to complete whatever the unbalanced force still left. That unbalanced force again should be distributed to the two members. So the remaining distribution process with the unbalancing force of minus 33. For making balancing I have to give 33 plus 33 and that 33 also with respect to the distribution factors I should have to add. So making involvement of distribution factors, this 33 should be given for two spans. And the next step we have given the condition, the unbalanced force for these I have got as minus 33 and plus 33 I should have to add for these two things. So plus 33 for 3 by 5 and plus 33 for 2 by 5 and the corresponding answers I have given here. As we have already completed the summation in the top, now the summing up we will go with the next line and the summation we have observed as with a solid line summation and these two summation, these two answer summation and the answer. Once you have given two solid lines, above answers not at all needed because those we came from the top condition only. So the below answers only we will add up and the answers we have given here. So when you observe here, once you do this step, when you observe here, if you have observed MBA plus MBC is becoming equal to 0, you can stop the calculation. So MBA plus MBC is becoming equal to 0, you can stop the calculation. Otherwise, again, the remaining unbalanced force, again 2/5 and 3/5 like that, we should have to complete the next cycle. Same like this, next will come. If these two summation is becoming equal to 0, you can complete, and after that we are closing the structure and indicating the answers, and finally we are going for the indication of the support moments. So the support moment answers we have indicated as at A 0, at B there is a hogging moment because of the resistance offered by the support. Okay, so it is resisting. So the beam, it is stopping in the both the conditions. It is trying to stop. But when you see, observe that you are observing the clockwise. But when you observe this, there is an anti-clockwise. That's why plus and minus appeared in the table. Plus minus appeared in the table. But what it is showing finally is that is hogging moment only. It is stopping. It is stopping like this. Okay, that's why hogging moment only I have indicated in the general way 31.8 hogging is occurring. And then at C also, at A also there is no movement. Okay, and we have given the actual bending moment diagram generation. For that we should have to indicate free bending moment diagram, and then we should have to indicate the support moment diagram, and summing up of these two you will get the actual bending moment diagram finally. So individual span, the corresponding and the bending moment diagrams we have completed separately. The maximum moment at the center we have calculated as WL square by 8 and WL square by 8. You should have to remember maximum moments for the simply supported beams, fixed end moments for the fixed beams. These two are very important for us. Okay, so using these two we will generate the free bending moment diagram, and merging those support moment diagram and the free bending moment diagram, you can evaluate or you can generate the actual bending moment diagram like this. Okay, 0 hogging moment at B, 0, and then free BMD in AB, free BMD in BC. Merging those two, you have actually got the bending moment diagram, that is the actual bending moment diagram. Now I am going for the evaluation of the shear force diagram. Okay, generate. But for evaluating or for generating shear force diagram for the continuous beam or for any type of beam, I need support reactions answer. Okay, so our next target is calculation of the support reactions. So we have done support moment calculation, and we have generated actual BMD. Okay, these two things were over. The next thing is support reaction calculation. So this support reaction calculation is how we will do. Up to this portion only, everything is different. So again, the remaining things are common for you. You itself generate what are the steps for support reaction. How you generate the support reactions? As there is a point like at the support, whatever is the support moment I am observing, that is the bending moment at the support. At the support point, the bending moment at the support point can be called as the support moment. So the support moments, as we have already know, they will help us in calculating the support reactions. How they will help us? As for the span, I can write what is the bending moment at the point, and that bending moment at the point is equal to support moment at the corresponding point. So making these two things, I can evaluate support reactions. So the next step is calculation of the support reactions or the actual support reactions. Okay. So for this, what we have said, I will use the bending moment answer. Okay, I am using bending moment at B answer so that I can evaluate VA when I consider the left span, or I can evaluate VC bending moment at B using VC answer I can generate when I use the bending moment from the right side. Okay, first I am going from the left side. Bending moment at B. bending moment at B is equal to only whatever the actual structure is there, that only I have written. Because in the problem, they have given like this only. Whatever the actual structure is there, that actual structures only I am drawing. Okay. So, here on the left side, you are observing VA, and here it is VB, and here it is VC. Okay. So, these three answers were there. Okay. Bending moment at B. What is bending moment at B? It is involving VA into 4 and it is involving 6 into 4 into 4 by 2. So, 6 into 4 into 2. This is the step we have done. VA into 4 minus 6 into 4 into 2. From the left span, that is the bending moment at B answer. But originally, actually, the support moment at B is as, see here I have observed VA into 4, that is positive. 6 into 4 into 2, that is negative. So, my sense, bending moment means considering saggings are positive, hoggings are negative. But actually, the support moment is 31.8 hogging moment. That's why minus 31.8 indication in case of sagging in nature. Why I have taken in this sagging natures? Because I have indicated bending moment in sagging format only. So, taking the saggings as a positive, hoggings as a negative, I have given this answer. So, the same nature only I should have to equate. So, in the same sagging nature, what is the answer? That is minus 31.8. Equating those two, VA into 4 minus 6 into 4 into 2, that is equal to minus 31.8, and we have got the VA answer for the original loading structure. So, that is 4.05 kilonewtons. And the next thing, just now only we have said, again we can come from the right side again at the same point. The next step is actual support reaction for the VC answer. So, coming from right side. So, at B towards 6. So, VC into 6. So, clockwise VC into 6 and 10 into 6 into 6 by 2. So, 10 into 6 into 6 by 2, and this way we have got the next moment due to the UL. So, VC into 6 minus 10 into 6 into 6 by 2, that is coming from the right side. And also we know one more thing. At B, there is a hogging moment of 31.8. Don't think from the table. Later we have given support moments with nature. Hogging moment of 31.8. But here, saggings are preferred for the positive. So, hogging means minus 31.8 I should have to write. Again, equating those two, we have got the VC answer. After getting VA and VC, the one more thing left is VB. From the vertical equilibrium, summation of all the upward forces is equal to summation of all the downward forces. VA plus VB plus VC is equal to total downward load of 6 into 4 plus 10 into 6. From that, we calculate VB is equal to 6 into 4 plus 10 into 6 minus VC minus VB. And summation these two, and VC and VA answers just now only we have got as 24.7 and 4.05. 24.7 and 4.05, and summation has given us plus 55.25 kilonewton from the vertical equilibrium. VA plus VB plus VC is equal to total download. From that conditional I have taken this. For the remaining two, I use bending moment concept. Bending moment at the support is equal to support moment. Bending moment at the support is equal to support moment. Using the two answers, we have generated VA and VC, and VB just now only we have got. So, after calculating the support reactions with this way, we have completed support reactions. VA is equal to 4.05. VB is equal to, and VC is equal to. So, these are the support reactions for the actual beam with the loadings. Now I am going for the shear force diagram generation, the actual shearing force diagram generation. Okay, so the actual shear force diagram, how we will generate it? So that for using the actual shear force diagram, I should have to indicate it with support reactions for the easy evaluation. Printing mistake, they have not given the dot for the decimal. So 4.05, 55.25 and 24.7, and I have given the UDL indication for the length 4 meter, 6 meter, 6 inch instant and intensity. So what we will do for the shear force diagram? We will consider span by span. Where the load is varying, at that point we will take the next span. So once you start from the left up to B point, it is having this reaction and UDL only. So the first section we can take from the left at a distance x. So considering a section in the span AB at a distance x from A. So the shear force at the section Fx is equal to left side upward plus 4.05 and minus 6 times x. So whatever is the intensity into length. And if x is equal to 0, it is indicating this A support. So 4.05 minus 0, that is 4.05 kilonewtons. And then the next thing is 4.05 minus 6 into 4, and we have got minus 19.95 kilonewtons. So these are the shearing forces at point A and at point B. Okay, and then for the BC, next I am going for the next section, because the same at the same section only the load is varying. See here, once you cross this, the reaction is varying and intensity of load is also varying. So at a time it is possible to take the next section. So once you cross point B, there is an involvement of 55.25 and also the load is varying. Only 4 meter length of 6 is there and also some length of 10 is coming next time. Okay. Now we are considering a section in the span BC at a distance x from A. Okay, so at a distance x from A. So consider the section in the BC at a distance x from A. Now what are the forces involved here? Left side upward Fx plus 4.05 and left side downward I am having a UDL of 6 into 4. Please don't forget, this 6 is not up to x length, this is up to 4 meter length only. 6 up to 4 meters. So the complete load is on the left side, and also there is left side upward 55.25, and on the left side there is a downward load of minus 10 into x minus 4, because x length only, this portion length is the 10 intensity UDL. So x minus 4 is the 10 intensity UDL's length. So in this way we have generated the shear force equation in the BC span at any distance x from A. Now when you see this, again you should have to indicate the answer. So 4.05, 55.25 minus 6 into 4 minus 10 into x minus 4. So this is our equation, and once you substitute x is equal to 4, it will have this term is equal to 0 only, plus 4.05 plus 55.25 minus 24, and the answer we have got as 35.3 kilonewtons at B, after the B. Okay, just to the left of B, on the right of B, only a simple addition of 55.25 happened suddenly, and then at x is equal to 10. So plus 4.05 minus 55.25 minus 24 minus 10 into 10 minus 4. So with that we have got the next answer for the shearing force at point C is minus 24.7, and you can say the shear force at the support is the support reaction. Shear force at the support is the support reaction at A and C. But what happened at B? It has taken two parts. For B towards A has got something. For B towards C we have got some value. The summation has given us this total of 55.25. Okay, don't think much. Only these first and last answers are the support reactions. You can cross check. Now I am developing the shearing force diagram. How we will develop the shear force diagram? Starting with this 4.05 kilonewton, positive left side upward 4.05, and then in the next span, AB span 4.05 to minus 19.95. So 4.05 to minus 19.95 we have got below the baseline, and the equation followed for this is 4.05 minus 6. So single degree straight line. So above the baseline and below the baseline, like that when you see from A to C using a single degree straight line. So here 4.05 we have got, and here 19.95 we have got, and then from that shear force there is the next span answer, and then at B we have got 35.3, and then at the other end minus 24%. So above the baseline, again above the baseline 35.3 and below the baseline 24.7. So again the connectivity is with a single degree straight line equation. In this way I have given the individual spans shear force diagram merging at a time. You can observe the picture. It may appear like this with 4.05 to 19.95, and then from the baseline up to 35.3 to the negative value of 24/7, indicating positives above the baseline, negatives below the baseline. We have completed our actual shear force diagram for the given structure. So in this way we will complete the calculation of support moments, support reactions, generating actual bending moment diagram, and generating the actual shear force diagram. So the complete analysis of a continuous beam will be done like this. Now we are going into the next problem. So the next problem we are having is a continuous beam ABC fixed at A and C. Which is being fixed at A and C and simply supported at B, and it is consisting spans AB and BC. So we are having a continuous beam with fixity at A and C and simply supported at B, and the span AB is 4 meter and the corresponding span BC is 6 meter. Okay. So only the support indications and length indications they have given. Now the span AB is carrying a UDL of 20 kilonewton per meter over the entire length. And the next span BC is having a UDL of 12 kilonewton per meter. Now find the moments and the reactions at the supports, draw bending moment diagram and shear force diagram. So we have done previously the complete analysis, calculation of the support moments, calculation of support reactions, generating shear force diagram and bending moment diagram. Okay. So once the support moments are over, we can generate the bending moment diagram, and then the support reactions, shear force diagram. So step by step we can generate. Now firstly, before entering into the generation of the bending moment diagram or the support moments, the main steps involved we should have to learn properly. When you see the actual loading figure, it may appear like this: fixed and A, fixed and C. B is simply supported with a distance 4 meters and 6 meters, and the first intensity is 20 kilonewton per meter, and this is 12 kilonewton per meter. So intensity of UDL per meter length. The main thing for calculation of support moments. So the support moment calculation is involving 3 main answers. Firstly, distribution factor calculation, and then fixed end moment calculation, and then development of distribution table, moment distribution table. So the support moment calculation involving distribution factor calculation, fixed end moment calculation, and then distribution of moments in the table. So these 3 steps combinedly will give the support moment answer. First step I am going on, distribution factor calculation. So the distribution factor calculation, how it will happen? This will be done only for the joints, so that we should have to develop a table. Okay, I am developing the table which is needed for us. And the first column is the joint. whatever the joint, you are generating the distribution factors. And then the next thing is members. What are the members connected? As I am going for the joint B, and the corresponding members are BA and BC. And the relative stiffness for the particular member is, if the farther end is fixed, relative stiffness should have a formula, that is, if the farther end at which I am calculating some joint, from this some farther end is there. So for this the farther end is A. Okay, when the farther end is fixed, the relative stiffness formula is I by L. If the farther end is hinged, nothing but if C is a hinged support or simply supported end, the corresponding distribution factor is 3/4 of I by L. So if the farther end is hinged, this is the relative stiffness. If the farther end is fixed, this is the relative stiffness. But for our original structure, from B, the farther end is fixed. From B, C, the farther end is, both are fixed. So the relative stiffness formula is I by L for both the members. I by length of the member. I by length of the member. How much we have got for the lengths? Those are 4 meters and 6 meters. And they have not given any moment of inertia are different. So I have taken I as it is. So 4 and 6. I by 4 and I by 6. Now the total relative stiffness. What is the total relative stiffness? That is I by 4 plus I by 6. So I by 4 plus I by 6, and then the distribution factor is equal to individual by total. Again, individual by total. So in this way we will complete the distribution factor. How we have done? Individually taking the relative stiffness, and then summing up these two, we have got total relative stiffness, and then individual by total, and cancelling I, we have got the ratio like this, and with the ratios we will get the table that may appear like this. So I by 4, which we have indicated as 3I by 12, and I by 6 we have indicated some other. If you are having calculus properly, you can calculate directly, and summation these two we have got as 5I by 12. So 3I by 12 by 5, that is a 3 by 5. 2I by 12 by 5 by 12, that is 2 by 5. So the distribution factors for the AB span and BC span purely based on length and moment of inertia. It will not involve any loading conditions, only length term and the corresponding moment of inertia, and also the farther end type or the condition. Based on the farther ending type, how it is, and what is the moment of inertia, and what is the length of the particular member. Using these 3 terms only, the particular member's distribution factor will come. Okay. So after getting this, what is the step 2 before entering into the support moment calculation table? That is calculation of the fixed end moment. So I am going for the fixed end moment calculation. Here again I am observing UDLs over the 2 lengths. So first being 24 meter. Next the 12, 6 meter. Okay, so AB, BC, and we will indicate it as WL square by 12 formula. You should have to remember repeatedly using. So WL square by 12, 20 into 4 square by 12, and here minus 12 into 6 square divided by 12, and plus 12 into 6 square divided by 12. So from the actual picture, what is the actual loading we are observing? 20 into 4 square by 12, 12 into 6 square by 12. In this way we have given the answers. So the fixed end moment calculation and the calculation of distribution factors was over. Now entering into the moment distribution table. So for drawing the moment distribution table, these are the answers we should have to write in the top line. So the next step I am starting, that is distribution moments of the table. How we are writing? Firstly I am indicating the joints as A, B and C. And then the distribution factors at B we should have to write with a line. Towards A we have got 3 by 5. Towards C we have got 2 by 5. See here. Whatever the values we are getting, that only I am writing B towards A, B towards C. So 3 by 5 and 2 by 5 are the distribution factors. And then the fixed moment answers minus 26.67 and 36. This one minus 26.67 minus 36 plus 36 plus 26.67. Only we are developing the moment distribution table with our structure. Okay, so the negative moment is indicating anti-clockwise nature, the positive is due to the clockwise nature. Again, negative anti-clockwise, positive is clockwise. So 26.67 and 36. The next step, generating the next part, joint names, distribution factors and fixed moments indication. Now, indication has appeared like this. And what we do the next? In the next step, if original structure is having simply supported ends at the ends, don't think about B, only at the original structure at the complete ends. If that end is having any simply supported end, the correction moment needed to be applied. But here our structure is having fixity at A, fixity at B. That's why as there is no simply supported end and the end correction moments not needed to be added. And the corresponding carryovers also will not be there. So from this step itself the moment distribution table will do. In the previous problem what we have done? We have not done for the direct for the moment distribution. Firstly we have completed the corrections for the simply supported ends. So after completing the simply supported ends corrections, then we came into the original distribution. Okay. Now we are directly going into the distribution. Okay. How it is starting? As we have said, at the joint, we are going for the direct distribution from the first step itself, as there is no support corrections. So from the first step our moment distribution is starting. Observation is observing at the joint. At the joint, these two summation should be equal to 0. At the joint, summation of moment towards A, towards C, the summation should be equal to 0. But here some unbalancing moment is there. So 26.67 and minus 36. What is the net unbalancing force we are having? That is minus 9.33. So that is still unbalancing in nature. So that for making it balance, I am adding plus 9.33. Okay. So minus 9.33, I am adding plus 9.33 and which will be added there. Okay. That total of 9.33, how we will add? Based on the distribution factor of the span. Yes. So in that 9.33, we will be distributing to the two spans according to their distribution factors of the span. Okay. So corresponding moments will be written as follows. Now plus 9.33 into 3 by 5. Observe here this table has some mistake while printing. The distribution factor for B towards A is 3 by 5 and it is 2 by 5. From the starting itself they are writing 2 and 3. So this is 3 by 5 and next one 2 by 5. So the net unbalanced force, that is 9.33, that minus 9.33 with addition plus 9.33 we are converting and plus 9.33 into the corresponding distribution factor 3 by 5. Multiplication has given us plus 5.6 and it will be written at the joint B towards B span. Similarly, plus 9.33 into 2 by 5, the corresponding answer is plus 3.73 and that answer will be written at a joint B towards C span. Okay. So in this way our first line has completed. As we are giving these forces, again the corresponding carryovers you should have to remember. As I am giving this, the corresponding carryover moments we should have to do. That corresponding carryover moments will be given with the same quantity but with half in this, with the same sign but with half a quantity. Okay. So as 5.6 is given with the positive sign, half of the quantity has given to the other end with the same sign. So half of 5.6 we have got plus 2.8 and plus 3.73 is there. Half of this will be carried over. Carry over moment is there. That carry over moment will be given. Why in the previous step we have not done this? Because there A is simply supported end. C is simply supported end. There is no carry over moment towards the supports. Here the support A and support C are fixed. That's why the carry over moment is there. Okay. The next thing, the vertical addition is happening. So here there is no separation with two solid lines. Why there is no two solid line? Because there we have given simply supported end separation and then we have given the moments. Here there is no simply supported ends. There is no separation. So till now we have not done any addition. So from the top till now, what are the values that we should have to add now? So from the top, minus 26.7, and just now I have got them as carry over moment. This one is carry over moment and this one is balancing moment. Okay, so and these are fixed end moments. So fixed end moments and then balancing moment and then the corresponding carryover moment, and it is additions. We have got the answers as it is additions in the vertical. As it is additions in the vertical, we have got these answers. Again, this step, whether you can stop here or you should have to continue. How we will observing those two values at the joint. So when those two values summation is giving equal to 0, you can stop the table here. Summation of these two tables is, two answers at B is equal to 0. We can stop the table here. Okay. Now after observing the joint, at the joint some of the moments of the members at BA and BC is equal to 0, the distribution method can be stopped. Like we see the joint equilibrium MBA plus MBC is equal to 0. So in this way our moment distribution table has completed and we will indicate the support moments like this. So the supporting moment at A is, this answer, that is minus 13.87. What it is indicating? At A, it is hogging in nature. Minus 23.87 is the final answer. So it is going in the anti-clockwise direction. So 23.87 hogging moment. And here this is in clockwise, this is in anti-clockwise. And finally at B I am observing hogging moment of 32.37. And at C I am observing a hogging moment of 37.87. In this way we are generating the moments. So the supporting moment at A is 23.87, supporting moment at B is 32.27, supporting moment at C is 37.87. Okay, so we have given the indication for the support moments like this. So the support moment step only we have completed. Right? So in the next step, using the support moments and using the free bending moment diagram, we will generate the actual bending moment diagram, and then we will generate actual reactions, and then we will continue for the shear force diagram. Thank you for today's session.